Hello, this is Daniel and nice to see you in another video. AI is becoming popular and machine learning is eating up everything. Today, I will introduce a series of easy machine learning tutorials for beginners. The presentation slides and source codes I used here were obtained from the Intel Machine Learning course. I reorganized the contents for easy understanding. You can download the original content from the website using the link here. Then, let's get started. Let's begin by explaining what machine learning is. Machine learning allows computers, software, or algorithms to learn, recognize, and predict from data. For example, in spam mail filtering problems, machine learning classifies emails as spam or non-spam emails. Besides that, many applications such as movie recommendations and speech recognition are rapidly growing. Machine learning, specifically supervised machine learning, is divided into regression and classification. In regression problems, the outcome is a continuous numeric value, such as predicting the house or Bitcoin prices. If we have predefined categories or classes we want to predict, like spam or non-spam, it is a classification problem. This slide shows how we build a predictive model with machine learning. Machine learning uses input data, where the answer, also called a label, is already known. We also need an algorithmic model. At this stage, we don't know the exact parameters or coefficients of the model. The fitting process uses the data to determine the model's parameters, which is called the training process. The trained model is then used to predict the new data's outcome or answers. Let's build a spam email detector. We use a lot of email data labeled as either spam or non-spam to train a model. This algorithm predicts a new unlabeled email as spam or non-spam. Today, we'll begin with the K nearest neighbors model, or KNN for short, the most widely used machine learning method. Let's see how KNN works. Let's say a doctor wants to predict cancer survival in patients. Historical patient data includes the patient's age, the number of cancer nodes the patient has had, and whether or not the patient survived. We can plot this historical data on a 2D coordinate space with the number of cancer nodes on the x-axis and the patient's age on the y-axis. We colored the points according to patient survival, where blue means survived and red means they did not. Now, a doctor wants to predict the survival likelihood of a new patient in a black point to decide proper treatments. We can intuitively predict the status of this patient by looking at and comparing nearby patients with similar features, age, and the number of nodes on the plot. We implicitly agree that the survival likelihood of the new patient is similar to that of nearby patients. It is the basic assumption that the nearest neighbor algorithm approaches. Then, how many neighbors should be considered? Here, the number of neighbors is noted as K. If we look at just one neighbor, the nearest neighbor, highlighted in red circle, we predict that the patient will not survive. If we consider the 3 closest neighbors with 2 patients that survived and 1 that did not, then we predict survived. That's a different result than when K equals 1. So what is needed to build the best KNN model? First, we must decide the number of neighbors. Second, we have to select the proper measure to calculate the distance of the neighbors. Let's focus on how to compute the distance between the two given points. What is proper distance between these 2 points? We will discuss 2 distance measures. The Euclidean distance is the most well known. It is very visual and easy to understand. Euclidean distance is also called L2 distance. The Manhattan distance, also called L1 or city block distance, is widespread. It is named after we can't walk directly between 2 points in a city. Instead, we turn the corner first to reach the destination. These 2 choices are the most popular. When calculating the distance, the scale of data is significant. Let's look at an example. The number of surgeries on the x-axis is relatively tiny, ranging from 1 to 5, relative to the patient's age, ranging from 10 to 60. The patient's age has a wide range variance, so it will dominate the distance calculation. The number of surgeries has little effect on the results, which may cause the prediction to be incorrect. Thus, in KNN, the feature values must be scaled by maximum absolute value, range, minimum or maximum, or mean variance. KNN is simple, easy to understand, and fast to implement since it doesn't do any actual training. However, KNN is slow to predict because of the heavy distance calculations. Plus, it requires a lot of memory to store the data. Okay, that's all I prepared for today, and thank you for listening.